Dr. Chuck the Science Schmuck.
Synchronize. This table is really dirty. I learned that yellow powder is really toxic to skin, and if you get it on you, it burns a lot. But burning off my skin is something I did off camera. What I'm doing now is fuzzy dice. Now, what are fuzzy dice? They are dice which are fuzzy. They're not practical dice. You can't gamble with them theoretically. You probably could, but fuzzy dice are a car ornament. They hang from your rearview mirror. Technically illegally, depending on the state, but it's useful because they give you plus 17 horsepower. These particular dice are very old. You can see they're green on some surfaces, but completely pale and white on others. These dice have survived 3 cars. One car, the engine blew up. That wasn't me. I didn't do it. The other car sunk in water about this deep, because that's how deep the water in Galveston is, in the roads. That was me. The current car is out there right now diceless. Why is there hot glue here? The problem being that these dice are in disrepair. They're probably 10 years old, and as you can see, they have begun to bleach. So my intention now is to do the mundane... Why is my hand shiny? The mundane task of repairing the dice. Now, you say, why? They're like $1, you could buy more. Well, the thing is inflation, I can't afford more dice. Also, I like these dice. Why not try to fix them? The question becomes, scientifically, why? The answer is, dice fade because they're in sunlight. Cars are pretty much constantly in sunlight. I don't own a garage. So they're constantly exposed to the light coming through the windshield. And that causes things... I have a clock that doesn't work up there. I didn't know that was there. But constant exposure to sunlight causes things to bleach. And that's an interesting proposition. Why do things bleach? Why is it that the dice, over time, go from having surfaces that look roughly like this to surfaces that look like this? The answer is in how organic dyes work, which fabric dye is an organic dye. I drew a diagram. This diagram probably doesn't make any sense at all, except to somebody who did a lot of organic chemistry, which, despite what people say, is actually a really fun class. It was one of my favorites in college, which I didn't do well in college, but organic chemistry was not the part I did poorly in. Essentially, organic dyes work on the principle of electronic resonance, which is partially described here, although it's a lot more complicated in actual dyes, which is when you have a system of carbon-to-carbon double bonds separated by single bonds, they don't actually render like this, because the ball and stick model of bonding is kind of not real. It's one of those things they teach you in like 8th grade that's just not really how atoms work. Like pretty much any chemistry they teach you in 8th grade isn't real. It's just sort of, except stoichiometry. That stuff's real. In actuality, when you have 2 carbon double bonds separated by a single bond, this is actually moving between itself. I need a pen. This is actually moving between itself such that it's not really 2 double bonds and a single bond, but rather it's a resonance. Which is in effect transferring between like a double bond here and single bonds here and radicals, and the electrons are constantly moving. That's why aromatics like benzene, something like benzene is drawn like that. There's imaginary hydrogens and each vertex is a carbon. But in actuality, that double bond switches over to this double bond, switches over to this double bond, so all those electrons are more or less in a circle, creating, a specific aromatic structure, which these electronic configurations in resonance are highly sensitive to photons. What is a photon? That's really complicated in a level of physics beyond me. I may have done well in organic chemistry, but I did not do well in physics, because there was math involved. And math has the wrong vowel. It's supposed to be a U. Snorting muff. But in effect, when an electron strikes, when a photon strikes an electron, quantum physics, basically. So A photon is a tiny quantized form of energy. It hits an electron, that electron jumps to a different energy shell, and then it falls back down, and a photon flies off. And depending on how much energy was imparted and then ejected, determines the frequency of light that comes off it, the color. Color is just a frequency of light. When the electrons are doing complicated things, not just in benzene is a transparent fluid, but when you have numerous of these, like stuck together in multiple resonances, and you have these giant crazy molecules, you have a situation where electron strikes, and now there's this whole bit, all the resonances start going crazy, and everything's transferring to everything else, and the energy isn't quite normal, and it can modulate the color response, so that when those electrons fall back, specific colors are emitted. And that's the basic principle behind organic dyes. They're a system of carbon and hydrogen, and sometimes other weird stuff like sulfurs and nitrogens, generally not metals. I guess you probably could put a metal in there. I don't know why you'd want to. That'd be a bad idea. Maybe even a halogen? I wouldn't. It'd make it too reactive. But it's usually basically just hydrocarbons in specific shapes. And these cause colors. That's what dye is. Sort of. The problem is fading. What is fading? It's a situation where you're looking at this specific chemical structure. So, if you were to draw this more realistically, this guy's probably, that's not a triple bond. This guy's probably got like a methyl. He's going over here. It's just a giant, complicated molecule. When very high energy photons strike a relatively sensitive molecule, like a big fat organic compound, they can blow pieces off. They can form free radicals. They can strip bonds away. That's the concept of ionizing radiation. Ionizing radiation breaks chemical bonds and makes them not what they were before. That's why if your DNA is exposed to ionizing radiation, it falls apart and you get DNA mutations that lead generally to tumors, although they can lead to other things. The most obvious is cellular death, which is why when you actually get irradiated, the first thing to go is the lining of your intestines. It's very unpleasant. But in the case of dye, ultraviolet radiation, which is ionizing radiation, strikes it, causes these electrons to go crazy and break. Something broke. It's no longer in the correct resonance. I'm touching all this yellow fluid that's super toxic and it's going to burn like crazy. But when it breaks, the dye no longer works. The dye fades. It disappears. It loses its ability to eject the same color frequency and basically becomes inert. And you say, well, that's not true of everything. And that is true. Certain chemicals, for example, the red in this pot. Ew, there's black stuff all stuck over it. Oh well. The red in this little pot. You could expose that to sunlight forever. It'll never really break down. Well, that's odd. Why does this fade but that doesn't? The answer is that pigment is inorganic. It's metal. It's iron oxide. Iron oxide is iron oxide, which is oxygen stuck together. The same thing is true of like copper. It's blue. Like copper sulfate is blue. I don't have any with me because it's really hard to synthesize, and all I can make is copper carbonate because it condenses in alkaline conditions. But those don't fade. Inorganic pigments don't fade because it's not a delicate bonds between things. It's actually the electronic structure of, like, say, a copper atom has a certain electronic structure when posed with a counterion where it does blue. Dice just moved on its own. I think they're haunted. But you would then ask, why can't you just dye the dice with an inorganic dye that never breaks down? The light, like, you could put copper sulfate in as much light as you want. It's never really going to, under normal ultraviolet circumstances, not be blue. It won't fade because it's not delicate like carbon-carbon bonds. The problem is mordant. So, the principle of dye in fabric, I wear a lot of dyed fabric, is that you need to take a dye and a fabric and squish the two together. And they need to bond. Or else when you wash it, they come apart. If you just took copper sulfate, which is very blue, and you put it on fabric, it would dye the fabric blue. But copper sulfate is very soluble, and the instant you get it wet, it will run out of the dye. It has no loyalty to the fabric, it just leaves. It's easier to bind big fat organics to, basically big fat organics is what fabric is made of. It's easy to stick those two together. Probably not, but okay, now metal things are moving over there. It's easy to stick those, but it's very hard to stick an inorganic dye. So fabric almost always uses some form of organic dye, whether it be organic, this is organic in a chemical sense, so carbon-based chemistry, whether it be synthetic, derived from oil basically, or other pigments, or synthetic materials, or a plant-based compound, which is similar in structure. Which means that no matter how I dye the dice, they will always fade, which is unfortunate. But in this case, I'm going to attempt to rejuvenate the dice by giving them a new dye job. I think. I hope. I'm going to turn them green again, or blue-green, some color, so that they'll be nice and new. And I think the first step to that is I'm going to have to remove the dots, unfortunately, because the dots have basically atrophied beyond usefulness. They have corroded and they're falling apart. And you can kind of see where the dots come off. There's still bright green fur because the dots have protected the fur from light. Now the dots, that's pretty, I removed the dot, but you can still see that was the one side. The dots are essentially stickers. The next thing I need is dye. I got dye. It's called RIT, which I think is something that kills lice. It works on algodón, lana, nylon, and moss. Eye irritant. Oh, great, there's instructions. Precauciones. Contiene sals y surfactants? It contains salt. Well, I contain salt. Not recommended for synthetic fibers, because synthetic fibers are chemically homogeneous in a sense. They're a repeating subunit of polymer that's not ideal to bond to versus a massive polysaccharide chain like cotton or actual animal protein like wool that's made of hair. So this may not work perfectly. Let's see. We wash fabric, remove all finish and stains. I don't need to do that, I don't think. Hottest water safe for fabric. Okay, so the process here is complicated. So apparently it requires adding hot water, which has been acidified, to dye, and then dipping the thing in it. Well, that's a lot less more complicated now. What's 140 degrees Fahrenheit? I'll assume it's 140 degrees Celsius, or Kelvin. You may be asking, why did I get Kelly green? The answer is, for some reason, it was a lot cheaper than all the other green. So I'm going to mix that up and see what I can do, or what I can get away with. Okay, now it's time to do some science. Firstly, I have repaired the dice by washing them. The string has also been removed. Not intentionally, it was made of nylon and snapped when I actually started to wash the dice. This is water, which was boiling a few seconds ago. I'm wearing thermally resistant rubber gloves, which are also probably dye-proof. My shorts are not hot water-proof, though. So, the instructions say, on the dye, lots of words I can't read. They say to add dish soap. I disagree with that. I will instead use laundry soap, which also contains an optical brightener. Roma is the best brand of soap. It took me forever to find it up here in New York. I believe the blue dots are the optical brightener. Optical brightener is itself a form of dye, although not a permanent one. Mix it with a stick. The instructions also say to apply vinegar to acidify the solution. I don't want to spill that. That stuff's useful. It said to add a certain amount. I don't care how much. Now, you may also wonder, why do I have this? I don't know. Actually, it's because I was trying to preserve, I shouldn't say what I was trying to preserve with that. However, alum, which is an aluminum compound, is a very efficient mordant used historically. I found it in my pantry while I was trying to scavenge for food. Also found the vanilla extract. Didn't even know I had it. A mordant is something that allows dye to attach better and more permanently to fabric. And I have not used this stuff in years, so I'm going to use it here, because why not? It's also in vaccines, interestingly enough. It induces a more efficient immune response to make vaccines more effective. It's quite non-toxic. I don't really want to eat it, although in some countries they use it as like a big brick of the stuff as a deodorant, which is kind of cool. This smells weird. Now to add the dye. It is time to dye. Oh, I was going to say, why is it white dye? It's because they put a childproof cap on it so that children can't drink dye. But eating lead paint is what got me this far. Which, it doesn't have a smell. Now I bought it only for this, so this is a little bit like dyeing Easter eggs, to be totally honest. I can use all the dye if I want to at this point. Because I'm not really going to use it for anything else. In fact, it looks like this. So to this material, I shall now add the dice. And I shall sink them into it. Die! 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 Die, die, die! Not me, I don't want to die. The dice need to die. The problem being that the dice themselves internally are foam and are floating instead of getting under there. Get in there. Stay down. Stay down. Well, I think it's safe to now sort of just meander along and bob for dice. So the dice, according to this stuff, need to sit in here for like 30 minutes. A thing about dye is that it initially covers the fabric, and they look well dyed, but in actuality they're not. It's just sticking to the surface and they haven't set yet. So it needs a while to dye. I'm going to let them sit in here for quite a bit in this very hot liquid so that they can absorb the green and turn back to their formal? I should have used formalin. Keep them nice and fresh. Turn them back to their former glory. Okay, well, they've been in there for a while, maybe 45 minutes or so. It's time to fish them out. Green, thick fluid. Now, the instructions call for, well, they're foam, so I need to bring them out. And I need to run them under water until the water is clear, removing excess dye. So I'm going to take them over to the science sink. Not drip on my pants, even though I've already bleach stained pretty severely from an unknown source of bleach. The water should also be cold. Good thing it's usually that way. Okay, it seems that it has effectively rendered them greener, repairing a lot of the fading, although not all of it. The next stage, I will need to repaint the dots, this time with paint instead of stickers. They have to be dry for that, so those need to cure for a while. And I need to figure out what to do with this dye, because it's liquid and I can't light it on fire. The fan behind the camera is lying on its side on the ground, and it slightly annoys me. Also, slightly off camera, there's a string dangling from the ceiling, moving back and forth nice and slowly. It's bothering me. In addition, there's a large trash can sitting right in the middle of the room instead of in the corner where it's supposed to go. Now, I would complain more about this, except I am the cause of all these problems. Literally no one else that I'm aware of lives here. Which doesn't explain the voices, but that's, you know. So anyway, regardless of whatever it is I'm thinking, These dice have died. I made them die. Which has resulted in them being green, more or less. Part of the issue is that the green die, which is now over on the die shelf, is not 100% the same color. Also, there's a matter of fading is still visible. Like you can see one side of the die is blue, the other side is kind of more of a pale greenish color. And that's kind of expected. It's not a perfect match. The dice are also slightly misshapen and not quite as soft as they once were. But they don't need to be soft. They're meant to hang from a car, so they're going to be a little weird. Also really rigid. That's probably the... They smell kind of nice too. It's probably the alum? Maybe? That's a weird taste. So now the question becomes the dots. Fortunately, because of the fading, the dots are pretty apparent on the dice. And you've probably... Quit thinking ahead of me. I can't even think that fast. I can't think fast at all. Because I have a tiny, tiny brain, which is an advantage. It's perfectly smooth and wrinkle-free. You can't brainwash me, it's already clean. I got a board with a hole in it. Now, that's not what you're thinking. It's a round hole, not a square hole. So the point of the round hole is that it's... So, board with a hole in it. Why a hole? It's because the hole is almost the same size as the spots that were on the dice, which are kind of floating around on my desk, adhered to it. And this stuff that burns my hands is apparently monoammonium phosphate. I really don't want to taste it, because I feel like those two things together make your bones fall apart if you eat it. So the idea here is to line up the dot over the hole on the die, and then put some black paint on it, which this is technically primer. An interesting thing, in many states, they don't allow you to buy spray paint as a child. I'm 43 now, so I can buy as much spray paint as I want. Ever wonder what that little dot thing moving around in there is? I figured it out in an earlier episode. But primer you don't usually need permission to buy. So this may go very poorly. So the idea here will be to line up the hole in the wood directly over the dots. I'm going to start with the ones, because that should be easy. And then spray paint, hold for a few seconds, release. Well, it's not exactly even or round, so that's a disadvantage. But you know what they say, close enough is close enough. Well, I'm back, and I don't know where I'm picking up off of because I made a video concluding this video, but that video didn't conclude properly because I took too long, I guess, in the computer. What am I even talking about? It corrupted. Moving the file over corrupted. I had to reformat the whole flash disk on the camera because it lost all my permissions, so I could no longer access the files on it, which is weird. There shouldn't ever be a situation where I don't have absolute permission to every file I create in a computer system, but I didn't design the camera, because if I designed it, it would point the wrong way. Cameras already have that option when they're in cell phones, so maybe I'm a genius? I don't think I'm a genius. If I was a genius, I'd be living in a bottle. Regardless of whether or not I live in a bottle, the dice don't look great, but they look pretty good. I don't know what that is, but it blew away. Mainly that's the two there. One is a little larger than the other. That's because when I went to put down the board, I held it wrong. I used the wrong end and got a big smear of paint. Because when you use it, one side gets covered in paint and the other side is mostly clear. And if you flip it over, that hits the other one. The other one looks more, I guess, reasonable. Still a little bit like I covered it in spray paint dots, but that's fine. It adds character. Like when, you fall in a lake and it's like, oh, it builds character. This is a chain. Where exactly it came from, I'm not 100% sure. At least in an original sense, I actually found it in a giant Easter egg with an Altoids tin. So that's normal. I think it came from a system to hold up fluorescent lights, but all my fluorescent lights are held up already, so I figure why not use it for this? Unlike the original nylon thread that connected the two dice, metal doesn't usually decay in sunlight unless you get it closer. As in, like, somewhere around where mercury is floating, you hold it out, and it can melt, but I don't intend for my car to be driving all the way to Mercury. That would be like a couple 1,000 miles at least? 1,000,000 miles? I don't think a car could drive to Mercury. It's too far for the car to go without needing an oil change. The last video that got corrupted, I sewed little, got a needle and thread, and I sewed little tiny loops onto the dice because this particular chain has hooks. So all I need to do is feed the hooks through the threads, and now you have, I think I might have suddenly realized what the fuzzy dice are meant to represent metaphorically in the car. It disturbs me, but not enough that I'm not going to continue with what I'm doing. I'm going to go put them in my car next time I'm there. You may notice that the threads are too long. The dice will hang down in front of my, interface, and if I turn too fast, they can swing around and hit me in the face, or you can, end up like that and get a dice torsion. And nobody wants a torsion. So one way to solve that is with this. You can't see it because it's extremely tiny. It's some magnets I found stuck on the side of a container full of cookies that's actually full of screws. So all I'm going to do is snap that between the two. Now I can hang the dies like that, and they look reminiscent of how they looked previously, except now they are more clearly dyed, and the dots are more defined and not falling off, even if one is giant. But that's fine. That's how I'll know if somebody stole my dice. It's like when somebody stole my bicycle, and I could recognize it because all the damage, I stole it back. Don't tell them I did it. So if anyone steals my dice, I'll know it was them, because I'll know these are my dice. And now my car will have horsepower once again. Scientifically not very interesting, but I got something out of it. New dice! Without even having to pay very much money, aside from like 6 or 7 times the cost of dice in dye, alum, and spray paint. So I call it a win. Extra.